Alright, our aim is to solve and graph linear inequalities. So let's start off with the obvious question, what is an inequality? Well, we know that this would be an equation if we had some value is equal to another value. So an equation is a mathematical statement that two things are equal, whereas an inequality, and that would be represented by this graph of this number line. On the number 3 on the number line, we would put a nice closed circle. The only number that makes this true is the number 3. Alright, so that would be what the graph of the equation x equals 3 looks like. Alright, so let's take a look at something slightly different. Let's say we had x is not equal to 3. That's an inequality. That's a statement that two values are not equal. So the question becomes, what values is x allowed to take on? Well, it's not allowed to take on 3, and one way we do that is on the value of 3, we actually use an open circle. Open circle is a statement that the value is not equal to that amount. So if we know that x is not equal to 3, we use an open circle. But what values is x allowed to take on? Well, it can take on the value of 0, it can take on the value of 1, it can take on the value of 5, it can take on all values. It can take on every value over here, and it can take on every value over here. So we indicate that by shading the number line in both directions, every value except for 3. Alright, this is kind of like a boundary point. This kind of tells us where things stop and start. Alright, so let's take a look at another example. So that's x is not equal to 3. Let's take a look at when x is greater than 3. Alright, so looking at that, on our number line, we've placed a circle on 3, and it's open because x cannot be equal to 3. Where would we place, what side of this line should we shade? Alright, so let's think about it logically. What numbers make this true? Well, if x has to be greater than 3, and by the way, I never remember which way means greater or less than. I have to read it from left to right. X is greater than 3, and I know that because this is facing this one, which means this is bigger, so I have to read it that way. X is greater than 3, so a number that makes this true would be 4. 4 is greater than 3, and 4 is located over here. 5 is also greater than 3, and 6, and so on. And all those numbers happen to be located on this side. Okay? So that would be the graph of x is greater than 3. If this was x is greater than or equal to 3, that's a very poorly drawn line, x is greater than or equal to 3, then in addition to all the values to the right, 3 itself would be a solution. So that's when we use a closed circle. So if you had to take anything from this so far, it's that the value will be where you place your circle on your number line. An open circle is for when things are not equal, and a closed circle is for when things are equal. Let's look at x is less than 3, and let's see what that looks like. That'll put a circle on 3 again. It's open in this case. Numbers that make this true would be numbers like 0, which is over here. Alright, and negative 5 over here. So this is the side of the line that we shade. Okay. Now a lot of students actually make up rules that aren't true. They think they're true, but they're not true. They say this, ooh, this arrow points to the right, so let me shade the right side. That's only true sometimes. It's not true all the time, so don't make up rules that don't work. Similarly here, it says the arrow is pointing to the left, so it must go this way. Also not true. Let's look at an example where that's not true. Let's say we had negative 5 is greater than x. Well, in that case, we have our number line. We place a circle on negative 5. In this case, it would be open. what values make this true? Negative 5 is bigger than what numbers? Well, negative 5 is bigger than negative 10, which is on this side. So we shade this side. Alright? So it's really not about where the arrow points, and it's not an arrow, it's a greater than symbol. That's a less than symbol. What it matters is what values make it true, and where are they located. In this case, they're located on the left, despite that the mouth is open this way and that the arrow appears to point this way. It's not an arrow. Alright? Other key thoughts that might be important. Let's erase this. Alright? So, x is greater than 3 is the same thing as 3 is less than x. Does that make sense? If I tell you x is bigger than 3, then 3 is less than x. Logically. So you can reverse any inequality. Some people like to do that because if you have it in this form, the arrow trick works. But in this form, it doesn't. Alright? So also, let's say we had x is less than or equal to 5. You can also say 5 is greater than or equal to x. It also works if there's an equal symbol. It works when you have an with an equation. If we had 5 is equal to x, you can reverse that. That's the same thing as x is equal to 5. Also, 5 is not equal to x is the same thing as saying x is not equal to 5. Alright, so you can reverse these things, but the important ones to notice are that if you have an inequality symbol, it has to reverse direction. Alright. Okay. Now, what else is important to mention about this? If you wanted to solve an inequality, let's say we had 3x plus 5 is greater than 10, it solves the same way you would solve any inequality. Subtract 5 from both sides. We'll get 3x is greater than 5. Now we would divide both sides. Wrong color. I meant to use blue. I picked black. Wrong choice. We'll get x is greater than, what is that? 1.6 repeating. And you can graph that on a number line. Here's the trick problem that comes up a lot. Let's say we were, and you can, graphing this on the number line, we get this value here, which is 1.6 repeating. X values that are greater than this, which are on the right. Greater is always on the right, if you think about it. Alright. Let's take a look at an example that's actually a trick example, and if you didn't watch the video, it'll be very evident tomorrow. Negative 3x minus 5 is greater than 7. 7? Nah, let's use 8. Alright, so we'll add 5 to both sides. Alright, and that'll give us negative 3x is greater than 8. Not 8. That's bad addition. Negative 3x is greater than 13. Okay. Now we divide both sides by negative 3. And that gives us x is less than 4 1/3. So negative 4 1/3. 0.3333. Okay, so I'm sure many of you are wondering, did I make a mistake? I reversed my inequality symbol, and the answer is no, I did not make a mistake. That's an actual rule, and I'll explain why the rule works. But the rule is if you multiply or divide both sides by a negative number, an inequality reverses. If you look over here, we actually divided by 3, which is positive, so it did not reverse. Here we divided by a negative 3, so it did reverse. So this would be plotted on negative 4.3 repetitive. Alright, so it's open because this is not equal. And let's add an equal to all of them, just so we have a different example. And so that would be a filled in closed circle. Values that make this true are smaller than this, which are located to the left. Smaller on the left. X is smaller than negative 4.333. Now, why does this rule work? This is the most important part of the video. Why does that rule work? Let's make up any number in the universe. Now, I'm literally just looking at the date and picking these numbers. 3/17. It's March 17th. What number is bigger? Obviously 17. Right? I could pick any two numbers in the universe. Alright? Matter of fact, just to make this interesting, I'll make this negative 3. Still true. Now, if I add any value to both sides, let's say I add 2 to both sides, I will get negative 1, and this will be 19. This is still greater. I will subtract any number from both sides. I'll subtract negative 9, subtract 9, which is negative 10, and this is 10, which is still greater. I will multiply by any positive number. I'll multiply by 2. I'll get negative 20, and I will get 20, which is still bigger. I will divide by any positive number. I will divide by 4. So dividing this by 4, we get negative 5, is still greater than 5. Now, when you divide by a negative number, if I divide these by negative 1, that becomes 5, and this becomes negative 5, which reverses the inequality. Alright, so here we added a positive. Here we subtracted a positive. Actually, I think, yeah, subtracted a positive, but it won't change if you subtract a negative. Here we multiplied by a positive. Here we divided by a positive. And here we multiplied or divided. Either way would be correct because it's by negative 1, by a negative number, and that reversed it all. So when we multiply or divide by a negative number, an inequality will reverse. Alright, and that's just true for any two numbers on a number line. You can try it yourself. Let's look at an example. This will be on your worksheet tomorrow, so I'm not really going to go into it too much. Let's solve this. First we'll distribute this negative here, and this here. So we'll get 5x is minus x minus 2 is greater than negative 5 minus 5x plus 3. Combining like terms, we'll get 4x minus 2 is greater than, combining these, that would be negative 2 minus 5x. We can now add 2 to both sides, and that gives us just 4x is greater than negative 5x. Now we can subtract 4x from both sides. That'll give us 0 is greater than negative 9x. And now we divide both sides by negative 9. And we'll get 0, I'm going to write it over here, 0 is less than x, because I divided by a negative number. I purposely did it that way. If you would have added the 5x instead, we would have got 9x is greater than 0, which would have said x is greater than 0, which is the same thing as this. So either way would give you the same result. So we can graph our answer on the number line, place an open circle on 0, and numbers that make this true are located on the right, like 0 is less than 1. So all those numbers. Alright, so that's kind of a rundown of how to graph an inequality, how to solve an inequality, and what we refer to as the golden rule of inequalities. And just to add some more reasoning behind the golden rule, I have like 30 seconds before this video stops working. If we take any two numbers, let's say this number and this number, and we multiply them by any negative, they will reverse. It will just switch. They will reverse on the number line where the positions are. And numbers over here are bigger, and numbers over here are small. So that's why it works.